37.1%. That is the score a small, cheap-to-run 8 billion parameter AI model just got on humanity's last exam. That's one of the absolute hardest reasoning tests ever built for AI. And this tiny model outright beat the massive GPT-5, which scored 35.1%. This data completely shatters a major myth in the tech world today. It breaks the deeply held assumption that a bigger model always equals better results. Welcome to the Explainer. Pulling off a score like that isn't just some tiny incremental update. It is a fundamental shift in how we build intelligent systems. See, for the longest time, the industry just assumed that to conquer really complex, multi-step problems, you simply had to throw more compute, more parameters, and honestly, more money at the problem. But this 8 billion parameter model pulled off a massive upset against a model literally many times its size. So to understand how it actually did this, we need to look at the mechanics of how AI solves problems right now.
Which brings us to Section 1, the expensive habit.
To understand how this tiny model pulled off such a massive upset, we first have to look at the underlying problem with how we are currently using AI. We are rapidly moving into an era where AI systems act independently to solve complex problems without you having to hold their hand. We call this agentic AI. And to do their jobs, these agents call on external resources, maybe a search engine or a calculator. That's known as tool use in plain English. But right now, well, the industry has an incredibly expensive habit when it comes to giving these agents autonomy.
Basically, today's AI agents try to solve every single problem, no matter how trivial, by calling the absolute most powerful, most expensive model at every single step. Imagine you run a business. The way we do things currently is the equivalent of calling your $1,000 an hour superstar consultant just to fix a typo in an email instead of delegating that basic work. It's just massively inefficient, right? The ideal state is reserving that superstar for critical strategy while handling the routine stuff way more cheaply.
That leads us to Section 2, Meet the Manager. A really fascinating new preprint paper from researchers at NVIDIA and the University of Hong Kong introduces a totally different approach. They started treating other AI models as tools that can be called upon. I want you to think of this new AI system exactly like a corporate team. At the center, you don't have a giant brain doing all the work. Instead, you have a smart junior manager. This is our 8 billion parameter orchestrator. Now, this manager's entire job is just to smartly delegate. It looks at a task and decides, hey, do I give this to our cheap generalists like basic web search tools, or do I route this to pricey specialists, maybe a math whiz or a coder? Or is this so complex that I need to call on that one superstar consultant who charges an absolute fortune per hour, which in this case is GPT-5? A good manager doesn't call the superstar for every single question, and this paper trains the manager to know the difference.
Which brings us to Section 3, the bias nobody trained out.
Now, you might be thinking, well, couldn't I just take any off-the-shelf model, write a clever text prompt, and just tell it to act like a manager? Actually, the researchers tried exactly that, and it completely failed. It exposed some really deep biases. When they took an untrained small model, in this case QN38B, and asked it to play the role of the manager, it acted out of sheer insecurity. It essentially panicked when faced with hard questions and called the GPT-5 superstar consultant on 73% of the tasks. It didn't matter if that massive brainpower was actually needed, it just defaulted to the strongest tool available and totally ignored the cost.
On the flip side, when they put the massive GPT-5 model in the manager's chair, it kept calling its own cheaper sibling, GPT-5 Mini, or just called itself, an astonishing 98% of the time. It completely ignored all the other highly capable specialist tools available to it. It acted out of pure habit and, frankly, maybe a bit of ego. So this proves that neither untrained model was actually making strategic, cost-effective decisions. They were just reacting blindly.
Let's move to Section 4, Teaching the manager to judge.
So, to fix this massive blind spot without using any overly complex equations, the researchers realized the manager needed to be fundamentally trained to understand real-world trade-offs. They trained the junior manager using trial and error with a strict scorecard, a process known as reinforcement learning. But instead of just rewarding the AI for getting the final answer correct, they graded it strictly on 3 specific things. First, did it get the answer right? Second, how much did that path cost in both money and time? And third, did it respect what the users specifically asked for? By forcing the model to optimize for all 3 of these metrics, they successfully taught the smart junior manager to weigh the price of a tool against the likelihood of success.
Let's look at the results in Section 5, the scorecard.
These verified numbers straight from the paper are the hard proof that this junior manager training absolutely worked. It shows exactly what happens when you prioritize strategic delegation over raw size. Across the board, the 8 billion parameter orchestrator beat the monolithic giant. On humanity's last exam, as we saw right at the start of this explainer, it hit that 37.1% compared to GPT-5's 35.1%, all while being approximately 2.5 times more efficient. Next, on frames, the orchestrator scored 76.3%, again beating GPT-5's 74.0%. And finally, on T-squared bench, the orchestrator triumphed with an 80.2% score against GPT-5's 77.7%. And get this, it did that while operating at roughly 30% of GPT-5's cost. The smart junior manager didn't just match the superstar consultant, it definitively outperformed it.
Which brings us to Section 6, the new hires test.
Now, a smart skeptic might step in here and ask a very valid question. Did this junior manager just memorize how to use its familiar team during training, or did it actually learn a truly transferable skill? To prove this wasn't just a memorized toolbox, the researchers ran a generalization result. They essentially gave the smart junior manager a completely new team of hires it had never worked with before. We're talking completely unseen models during training, including Claude Opus 4.1 and Claude Sonnet 4.1. And the results were stunning. Even with these brand new tools, the manager immediately understood their strengths and weaknesses, and it still made the absolute best calls at the lowest possible cost.
As we saw a moment ago with those untrained models that just panicked, true intelligence in an agentic system isn't just about having the biggest brain. It's knowing exactly who to call. The manager perfectly balanced and strategically distributed tasks across diverse experts. It proved it actually learned the core essence of management: how to run a diverse team, delegating appropriately to those cheap generalists and pricey specialists, and only calling in the superstar when absolutely necessary.
So why does all of this matter to you? Well, for those of you managing teams, building products, or deploying these tools in your companies, the ultimate takeaway here is that cost and speed are rapidly becoming the real bottlenecks in agentic AI, not raw intelligence. You do not necessarily need a massive, wildly expensive model to get industry-leading results. Efficiency, not raw size, is becoming the real edge in AI systems. It is a hugely useful lens for evaluating AI vendor claims that lean purely on benchmark scores without ever mentioning the cost.
I'll leave you with this provocative question to take back to your own teams. When you evaluate AI vendors, are you looking at the true cost of their benchmark scores, or are you just being blinded by raw size? I highly encourage you to check out the full Tool Orchestra paper for the rigorous technical details behind this fascinating shift. Thanks for joining me on this explainer, and keep asking the hard questions.